Hi everyone, I welcome all of you to my channel, and as I promised you in my last video that I'll be bringing another video on the property of tan inverse functions. So here I am with the property 6, that is tan inverse x plus tan inverse y, and you can see that there are three important properties of tan inverse x plus tan inverse y functions, and based on the value of x, y and x and y. Okay, now in this video we will be discussing completely this property 6 only. Okay, so first what I am going to do is, first I am going to discuss the proof of tan inverse x plus tan inverse y equal to tan inverse x plus y divided by 1 minus xy for xy less than 1. Okay, so we are going to discuss this first property in details. And since it's given this xy less than 1, so the individual value of xy is not given. So there could be many cases for the first property. The first case could be that x is greater than 0 and y is greater than 0, and xy less than 1 obviously will be fixed. So first we are going to discuss that. Okay, what is the first case we are going to discuss is this. Okay, this is property 6. Okay, what is the property? Tan inverse x plus tan inverse y equal to tan inverse x plus y upon 1 minus xy. Right? X plus y upon 1 minus xy, provided, what is the restriction given? Here it's given xy less than 1. So we are going to discuss this proof with the help of different cases. The first case we are going to take that case 1. What is the first case? Let x positive and y also positive and xy already given as less than 1. So this is the first case. Okay, we'll assume this tan inverse x and tan inverse y. Let tan inverse x equal to A and tan inverse y equal to B. So this implies, okay, x is equal to tan A and y equal to tan B. Now since x is tan inverse x is equal to A and tan inverse y equal to B, so you can just write the value of AB. So AB belongs to minus pi by 2 to plus pi by 2. We know the value of A and B. A lies between minus pi by 2 to plus pi by 2, and B also lies between minus pi by 2 to pi by 2. Since because the tan inverse x is equal to A. Okay, now we know the value of tan A plus B functions. So we know tan A plus B. Okay, what is tan A plus B? Tan A plus B is tan A plus tan B divided by 1 minus tan A tan B. So now what is the value of tan A? And tan A is equal to x and tan B equal to y. So we can just write this, that x plus y 1 minus xy. Now this is a very important relations. Tan A plus B is equal to x plus y divided by 1 minus xy. Now what is the value of x? X is greater than 0. Since x is greater than 0, okay, x is greater than 0, and therefore, and what is x? X is tan A, right? And A lies between minus pi by 2 to pi by 2. And since x is greater than 0, so hence tan A is positive. So if tan A is positive, A belongs to 0 to pi by 2. That means A lies between 0 to pi by 2, A in the first quadrant. Why? Because A lies between minus pi by 2 to pi by 2. And here, according to this the first case, we have taken x is greater than 0. If x is greater than 0, what is the value of x? Tan A. Tan A should be positive. So from minus pi by 2 to pi by 2, where tan A is positive? Tan A is positive from 0 to pi by 2. So naturally A belongs to 0 to pi by 2. So similarly, like y greater than 0 implies what? What is y? Y equal to b. So the similar conditions, b will also lie between 0 to pi by 2. Now let us club this together, a and b. So if we just write a and b plus, so here, okay, a is greater than 0 and less than pi by 2, and b is greater than 0 and less than pi by 2. Done. So if we add this, 0 less, if we add this, a plus b and pi by 2 plus pi by 2, it's pi. So a lies between, that is a plus b lies between 0 to pi, a plus b. Now, see the sign of this value, x plus y divided by 1 minus x y. Let us see the sign. Okay. Now since x is greater than 0, y is greater than 0, x, y less than 1. Now, what is the sign of x plus y divided by 1 minus xy? This is very important. The sign. Here x is positive, y is positive. So x plus y is positive. Now what is the denominator? 1 minus xy. Since xy less than 1, this means xy is less than 1, so this is also positive. So definitely this is positive. X plus y divided by 1 minus xy is positive. Now what is the value of x plus y divided by 1 minus xy? It's equal to tan a plus b. So that means if x plus y divided by 1 minus x is positive, so this value, tan a plus b is positive. Okay. Now if tan a plus b is positive, okay, and where does a plus b lies? A plus b lies between 0 to pi, either first quadrant or the second quadrant. Okay, first quadrant or second quadrant, and tan a plus b should be positive. So therefore, with the help of that logic, you can just say therefore a plus b should lie between 0 to pi by 2. It's very clear from the given the restrictions. Okay, from this one already I explained that a plus b lies between 0 to pi. So a plus b, there is a possibility that means in the first quadrant or the second quadrant. But according to this case, okay, we know that x plus y 1 minus xy. So what is x plus y divided by 1 minus xy is equal to tan a plus b. So if tan a plus b is positive, therefore a plus b should lie in the first quadrant or the third quadrant. Okay, but here the a plus b lies between 0 to pi. So we need to check first quadrant and second quadrant. So since second quadrant, this tan a plus b will be negative, therefore a plus b will be lying between 0 to pi by 2. Now, if we just mark this one as an important equations, that is tan a plus b equal to x plus y 1 minus xy, we need to see the value of a plus b now. What is a plus b? A plus b actually lying between 0 to pi by 2. So since a plus b lying between 0 to pi by 2, so we can definitely write that a plus b, so you can just write this equation implies a plus b is equal to what? Tan inverse. Why you can write tan inverse? Because we know that a plus b lying between 0 to pi by 2. So therefore a plus b is tan inverse x plus y divided by 1 minus xy. Now let us replace the value of ab. What is a and what is b? So this a is equal to tan inverse x and b is tan inverse y equal to tan inverse x plus y divided by 1 minus xy. Done. So this is the first proof. The proof is very simple. Okay, this is the first proof. We have the first case. Let us discuss what are the other cases possible. Okay, so just take the case 2 now. What is case 2? What is case 2? Let x less than 0, y less than 0, and xy is already less than 1. It's already given. So we're just taking this case x less than 0, y less than 0. So just if we can refer to the previous proof, and already we have written this particular expression, that is tan a plus b is equal to x plus y 1 minus xy, right? This relation is there with us. Now most important is, now we'll check the sign of this. Okay, since x is less than 0, y is less than 0 and xy is less than 1. Now x plus y 1 minus xy. Let's see the sign. So here x plus y both are negative. So therefore x plus y is negative. Now xy is less than 1, that means 1 minus xy is positive. So this is a positive term and this is negative. So therefore it's less than 0. Since x plus y 1 minus xy is less than 0, so what about tan a plus b? This is tan a plus b also negative. If tan a plus b is negative, where does a plus b lies? So therefore a plus b lies in which quadrant? Quadrant 2 or quadrant 4. Because we know that in the second and the fourth quadrant, tan is negative. Now, most important, the value of AB. Okay. Now, just see here, x is less than 0. Since x is less than 0, therefore, where does A lies? Now, we have taken that tan inverse, remember this, tan inverse x is equal to A. We have taken this tan inverse x is equal to A. Therefore, x is equal to tan. And as because we have taken tan inverse x equal to A, where does A lies? Already we have just mentioned in the previous proof. You remember that A plus B always belongs to minus pi by 2 to pi by 2. Done? Okay, minus pi by 2 to pi by 2. Now since A lies between minus pi by 2 to pi by 2, what is the value of x? X is tan A. Now here x is negative. So this tan is negative. So if tan is negative, so since x less than 0, so A obviously will lie between minus pi by 2 to 0. So A has to be lie between minus pi by 2 to 0. If A lies between minus pi by 2 to 0, then only this x will be negative. Okay? And similarly, since y is than 0, so B also lies between minus pi by 2 to 0. There are two options. Either A will lie between minus pi by 2 to 0 or 0 to pi by 2. In case if A lies between 0 to pi by 2, then the x will be positive. But here that case is ruled out. That already you have done in the previous proof. So now let us see where does A plus B lies. Because our most important angle is A plus B. Let's see that. Okay. Since A lies between minus pi by 2 to 0 and B lies also between minus pi by 2 to 0. So if we add this, so it will lie. So if you add this minus pi by 2 plus minus pi by 2, it's minus pi. So A plus B and 0. That means A plus B lies between minus pi to 0. This is a very, very important angle. Remember this. So we have seen that A plus B lies between minus pi to 0. Now see these steps. A plus B, because out of this 2, okay, we need to restrict the value of A plus B. So here A plus B lies in quadrant 2 and quadrant 4. And here it's A plus B says it's A plus B is lying between minus pi to 0. Minus pi to 0. So if it is A plus B lying between minus pi to 0, so A plus B can be third quadrant or fourth quadrant. Now here A plus B lies in the quadrant 2 or quadrant 4. So combining these two, okay, combining these two, you can say that A plus B will be lying actually in the fourth quadrant. So this implies, you can just write that, so you can just imply with the help of this and this, okay, and therefore A plus B, okay, will be lying between minus pi by 2 to 0. That means A plus B will be lying in the fourth quadrant. So I just repeat one thing, like A plus B lies in quadrant 2 or quadrant 4, and with the help of this restriction we got A plus B lying between minus pi to 0. So minus pi to 0 means it will be either third quadrant or fourth quadrant. So here fourth quadrant is there, and here also fourth quadrant is there. Fourth quadrant is common, so therefore A plus B will be lying between minus pi by 2 to 0. Since A plus B will be lying between minus pi by 2 to 0, so let me write this formula once more. Like we know tan A plus B, tan A plus B equal to, what is tan A plus B? X plus y divided by 1 minus xy. Done? Right? Now A plus B lying between minus pi to 0. So actually this A plus B is lying in the range of tan inverse. So we can write the next step as a plus b equal to tan inverse x plus y upon 1 minus x y. Done? So now only you need to replace the value of a and b. What is a? A is tan inverse x and b is tan inverse y equal to tan inverse x plus y 1 minus xy. Done. So this proof also looks equally very simple, and this is the proof for case 2. So let's see that is there any case left out. Okay. So what are the two cases we have done? For the first case, what we have done? The first case we have done for x is greater than 0 and y is greater than 0. Second case, what we have done? That x is less than 0 and y is less than 0. Okay, these are the two cases we have done. So what is the third case we are going to do it? Okay, the third case, that is case 3. So case 3, what I am going to do is, case 3 is let, okay, x is greater than 0 and y is less than 0. This is the third case. Okay, that is x is greater than 0 and y is less than 0. Since x is greater than 0, therefore we can just write, okay, a, that is a value, okay, that a value lies between 0 to pi by 2. Then a lies between 0 to pi by 2. Why? I just can repeat once, like, okay, tan inverse x equal to a, therefore x equal to tan a. Now since we have taken this x is what? This x is positive, so since x is positive, so therefore a lies between 0 to pi by 2. 0 to pi by 2, and since y is less than 0, so b lies between, okay, y is less than 0, so b lies between minus pi by 2 to 0. What is the reason for that? Already I have just explained. I'll tell you one thing. So like x greater than 0, why a will be lying between 0 to pi by 2? Because we know that a belongs to minus pi by 2 to pi by 2, and b also belongs to minus pi by 2 to plus pi by 2, right? A, since we are assuming that tan inverse x is equal to a, right? Tan inverse x is equal to a, therefore a lies between minus pi by 2 to pi by 2, and b also lies between minus pi by 2 to pi by 2. And here it's given that clearly x is greater than 0. So x is greater than 0, so minus pi by 2 to pi by 2 means what? Either in the fourth quadrant or in the first quadrant. But therefore, since x is greater than 0, so clearly you can write a belongs to 0 to pi by 2. That means there is no chance that it will lie in this fourth quadrant. So x, a value is lying between 0 to pi by 2. Similarly, y less than 0. So here we have taken y less than 0. So if y is less than 0, so y cannot, that is b value cannot lie in the first quadrant. So there is only one chance it will be lying in the fourth quadrant. Why? Because the b value lies between minus pi by 2 to pi by 2. Either you need to check in the fourth quadrant or in the first quadrant. So since y is less than 0, so I'm going to lie in this quadrant. So if we add this, so a plus b, right? A plus b. Since a lies between 0 to pi by 2, b lies between minus pi by 2 to 0. So a plus b will lie between minus pi by 2 to pi by 2. I hope like this should be not difficult for you to understand these steps. Okay, so I can just explain these steps once more. Okay, what is this steps? How did I get this? So I can just write once more steps. Okay, so refer to these steps. Okay, a belongs to 0 to pi by 2. So a is greater than 0 and less than pi by 2, and b is greater than 0. No, b is greater than minus pi by 2. So this is minus pi by 2 and less than 0. If we add this, minus pi by 2 plus 0 is minus pi by 2, and a plus b and pi by 2 plus 0 is a pi by 2, right? So that's what I have written, that a plus b lies between minus pi by 2 to pi by 2. So have you seen that? Since a plus b lying between minus pi by 2 to pi by 2, this is actually the range of tan inverse. So this implies, therefore you can just write from the given formula, that is tan a plus b is equal to x plus y 1 minus xy. This implies, this is the formula. So since a plus b lying between minus pi by 2 to pi by 2, so the next step you can write a plus b is equal to, okay, a plus b is equal to tan inverse x plus y 1 minus xy. That's done. Simple proof. Okay. Then you need to replace the value of a and b. What do you say? A is tan inverse x and b is tan inverse y. Therefore, tan inverse x plus tan inverse y equal to tan inverse x plus y divided by 1 minus xy. In case x is greater than 0 and y is less than 0. I hope like the fourth case. What will be the fourth case? That is x is less than 0 and x is less than 0 and y is greater than 0. That is left for you because that proof will be exactly similar to this. Okay, so with the help of the case 1, 2, 3, okay, and 4. So just can prove this will be the complete proof of the first property. Therefore, you can just write that from all this, okay, all this cases, that is 1, 2, 3 and 4. Of course 4 you need to prove by yourself. From all these cases, okay, so you can just write what you can write, that is tan inverse x plus tan inverse y equal to tan inverse x plus y divided by 1 minus xy. So this is a very useful formula, that is a property of inverse trigonometric functions, and we have proved for all the cases. Today in this video we are just going to prove one more, that is the property 2. We are going to prove it. That is also a very important. A proof could be a little different than this. I'm just going to prove the second property, and similarly I'll just leave the third property for you to prove. Okay, so what is the properties, the second property? Let us see this once more. Okay, what is that? So we are going to prove this, that the second property, that is tan inverse x plus tan inverse y equal to pi plus tan inverse x plus y divided by 1 minus xy, where xy greater than 1. Remember this. Here this is different. Here xy less than 1, and here this one. That is okay, here, yeah, here you have to see this, xy is greater than 1, and of course here the x and y value is already given. X should be positive and y should be positive. Okay, so just going to prove this. Okay, the second property. What is the second property? Let me write once more. Tan inverse x plus tan inverse y equal to pi plus tan inverse x plus y 1 minus xy. We are going to prove this. What is the conditions given? We are going to prove this. Okay, so here remember this, x is positive and y also positive, and apart from this it's given that product of xy is greater than 1. Okay, product of xy is greater than 1. So we know, since already these are the steps we have already done, so we're just going to write this formula directly. We know that tan a plus b, okay, equal to x plus y 1 minus xy. Okay, this formula already we have used for the previous two proofs. That is tan a plus b is equal to x plus y divided by 1 minus xy, and here we are assuming that what we have assumed, that tan inverse x equal to a and tan inverse y equal to b, and apart from that, remember this, that a comma b belongs to minus pi by 2 to plus pi by 2. Done. Okay. Now let us see the sign of this. Okay, the fraction, that is x plus y divided by 1 minus xy. So since x is greater than 0, y is greater than 0, okay, and xy is greater than 1, this implies x plus y 1 minus xy. Okay, so these both are positive, so this, the numerator x plus y is positive. But have you seen this, xy is greater than 1, this one is greater than 1, so therefore it gives us a negative value. So as a whole, this is positive, this is negative, is less than 0. Now, since tan a plus b is negative, okay, this is x plus y, 1 minus xy is less than 0. So hence, tan a plus b is less than 0. So if tan a plus b is less than 0, where does a plus b lies? So therefore, a plus b lies, okay, a plus b lies in which quadrant? Okay, it's negative in quadrant 2 or quadrant 4. Okay, we know like tan is negative in second quadrant or fourth quadrant. Now most interesting fact here is, okay, we need to decide where does actually a plus b lie based on the value of ab. So where a and b lies, let's see that. Okay. So and apart from that, let us see that where x is greater than 0 and here x is greater than 0, y is greater than 0. Right, since x is greater than 0, okay, therefore simple a belongs to what? 0 to pi by 2, done. A obviously will be lying between 0 to pi by 2, and already I explained these things in the previous the proof. So y greater than 0, so therefore b also will be lying in between 0 to pi by 2. Now since a lies between 0 to pi by 2, b lies between 0 to pi by 2, from this we can just write, combining these two, we can just write, okay, a is greater than 0 and less than pi by 2, and b is greater than 0 and less than pi by 2. So this implies a plus b is lying between 0 to what? Then if you add this, a plus b, 0 plus 0 is 0, pi by 2 plus pi by 2 is pi. So have you seen that? So a plus b actually lies between what? 0 to pi. Now, interesting fact about this, that now since a plus b we know, like with the help of the given restrictions, a plus b lies between 0 to pi. So from this steps, can you write a plus b equal to tan inverse x plus y? We can't. The reason behind that, tan inverse, the range of tan inverse actually not lying between 0 to pi. Done. So therefore, we need to manipulate this. We first will compare this a plus b lying between 0 to pi and where does a plus b lies. Okay, see that. A plus b lies in quadrant 2 and quadrant 4, and here a plus b lies between 0 to pi. So we can compare these two, and with the help of this two statement, we can decide where does a plus b lies. Here a plus b lies in quadrant 2, quadrant 4. Here a plus b lying between 0 to pi. So 0 to pi means first quadrant or the second quadrant. Here a plus b lies in quadrant 2 or 4. What is common there? With the help of this two statement, we know that quadrant 2 is common. So therefore a plus b will be lying between. Okay. So what you can write after this? So I'll just repeat once. Like here a plus b lies in quadrant 2 and 4. Here a plus b lying between 0 to pi. 0 to pi means first quadrant and second quadrant. And according to this statement, a plus b lies in quadrant 2 or quadrant 4. So that's quadrant 2 is common. So a plus b lies in quadrant 2. So this implies a plus b will lies in quadrant 2. Quadrant 2 means what? Pi by 2 to pi. Done. A plus b lies between pi by 2 to pi. Done. Okay. A plus b lying between pi by 2 to pi, but still that it's not lying between minus pi by 2 to plus pi by 2. So why do we need the angle should lie between the range of tan inverse? Because we know like that here tan a plus b is equal to tan inverse. Okay, it's given tan a plus b is equal to x plus y 1 minus xy. Done. Okay, this is the formula, right? Now just we have to write, take the inverse of tan, that is a plus b should be tan inverse. But where does a plus b lies? A plus b lies between, this is, have you seen that? Between pi by 2 to pi by pi. So therefore we are going to manipulate this particular formula. Okay, this specially designed. So how to do that? So just going to do that. We'll just take a minus sign and just write tan pi minus. Okay, tan pi minus, this is a plus b. Then can you write like this? Tan pi minus a plus b. You can write because tan pi minus theta Okay, tan pi minus theta is minus tan theta. So minus minus will be plus. So you can just, in place of tan a plus b, you can write minus tan pi minus a plus b. So it's equal to x plus y, 1 minus, like this. In fact, similar expressions we have done in the previous proof. Okay, so what I am going to do is, we'll just insert this minus sign. So if we insert, so it will be tan a plus b. So we just insert means we will multiply this angle. So minus a plus b will be plus a plus b, and pi will become minus is equal to x plus y. That means from this given expressions, we have converted this a plus b angle to the form of a plus b minus pi, because we have seen with the help of this steps, tan a plus b minus pi is exactly same as tan a plus b. I can repeat the steps once more. Tan a plus b, just take a minus sign there, and this a plus b write in terms of tan pi minus theta. Tan pi minus theta is equal to how much? Minus tan theta. Okay, you can see that. Okay, tan theta is equal to minus tan pi minus theta. It's exactly same. Tan theta can be written as minus tan pi minus theta. So what is theta here? Theta is a plus b. So tan theta is written as minus tan pi minus theta. So now we don't need the minus sign. We'll multiply the minus sign. Why can multiply? Because we know like tan minus theta is same as minus tan theta. Yeah. With the help of this logic, we shall just write that. Okay. Now this is a very important expressions. What is the angle now? A plus b minus pi. Okay. We know like a plus b lying between. Now a plus b lying between pi by 2 to pi. Already I explained about that. But this a plus b I will be converting to this form, that is a plus b minus pi. So what I am going to do is, I will subtract pi from its term. Okay, that is pi minus 2 minus pi, a plus b minus pi. Okay, a plus b minus pi, and pi minus pi is 0. So this implies, okay, pi by 2 minus pi is what? Minus pi by 2, and this is a plus b minus pi less than 0. Done? So have you seen that with a plus b minus pi lying between minus pi by 2 to 0? That means this, in case if you convert this angle to this angle, so we are in a position to take tan inverse. So what is the next steps? So next step is this, that is a plus b minus pi equal to tan inverse x plus y 1 minus xy. Done? So what is the next step now? A plus b equal to pi. If you transpose pi plus tan inverse x plus y upon 1 minus xy. Done? So just don't need all this. So we'll just replace this now. We'll replace this. So what is the value of a? Tan inverse x plus tan inverse y equal to pi plus tan inverse x plus y minus 1 minus xy. Done? So this is another very important property of inverse trigonometric functions, and proof as simple as possible that I tried to explain you. I hope just please go through the video and then you practice yourself, and I hope it will not be very difficult. Alright, so and there is one more property here, and that property will be similar to this, so therefore this is left for you. And thank you so much for watching my video, and in the next video we have got more property, because initially I say that inverse trigonometric function has got more properties. Okay, so unless we complete the properties, we will not be able to solve sums. Okay, because the questions can be a combination of application of many other properties. So therefore, we're not starting this question answers now. Then the next video, then I'll be coming with some important properties. Of course, after that, maybe just we'll be able to start question answers on inverse trigonometric functions. Thank you so much for watching my video, and take care, and bye bye. Thank you.